Hello everyone. In a previous video, we created an effect where Niagara and materials sampled a triangle of skeletal mesh, and in this video, we'll sample them in a static mesh. This method correctly samples every triangles of the mesh. Of course, we can also use different materials in Niagara to enrich the visual result, for example, removing the center mask to create a wireframe effect, or adding dynamically colors to the material for a more interesting style. Now, let's see how to create this effect on a static mesh. First, open Niagara. This setup is quite similar to the previous video. We manually create a module to sample the triangles, but since we're now using static mesh instead of skeletal mesh, the way we get the required parameters is slightly different. For example, there are no skinning options. We directly sample the vertex data in world space. Because the overall approach is similar, I won't go through the entire setup again, but I will explain how it works. In short, the module sets each particle's position and parameters, such as correct sprite size, facing, alignment, and rotation, based on the corresponding mesh triangle. We also need a suitable material to use within Niagara. If anything is unclear, don't worry. I'll share the complete Niagara system on my Patreon for free download. Next, let's look at how it works in detail. Here's the material we use in Niagara. It's a simple triangle material. By default, the sprite material is square, but meshes always use triangles, so we create a triangle mask in the material to match the mesh triangles. For example, here we have 3 points, A, B, and C. We need to map the material's 3 points to the triangle face of the particle. One edge, like AB, can be fixed. This means the edge AB won't move, only point C will be shifted using world position offset to get the correct positions of all 3 points. We also need to set the material's default pivot in UV space in Niagara to 0, 0.5, so that the particle's origin lies at the midpoint of AB. Then we calculate the sprite facing. It should be perpendicular to the triangle. We take the cross product of vector AB and vector AC to get a vector perpendicular to both, and use its direction as the particle facing. Once position and facing are set, we also need the alignment. Simply take the direction of vector AB. This aligns the particle to the edge AB and ensures it lies within the same plane as the corresponding mesh triangle. Next, we calculate the particle size. The length of vector AB corresponds to the sprite size y. For the size x, we take the perpendicular distance from point C to line AB. This is get from the cross product of the normalized AB vector and vector AC. Then, we move point C to the correct position in world position offset. The offset is based on the dot product of the normalized AB vector and vector AC, multiplied by the direction of vector AB. We pass the calculated offset values to the material through dynamic material parameters, giving us the 3 axis values, x, y, z for moving point C. As mentioned earlier, the gradient mask ensures the edge AB remains fixed while only point C moves. That's how we reconstruct the full mesh in Niagara. Now let's test it. Add a new static mesh and a Niagara system. Then attach the Niagara system to the mesh. One more thing, we must match the spawn count to the number of triangles in the mesh. The mesh has 12,554 triangles, so we set the count in Niagara to 12,554 as well. Perfect. Let's try it with another mesh and set the material to transparent. Yes, it works on any static mesh. We can also modify the material. For instance, keep only the wireframe border and add dynamic color changes to make it look even cooler. So that's all for this video. I hope you enjoy it. Bye.